structure of the sun. I thought that video was a nice introduction. It's basically covered everything that we will be going over today. So first and foremost, we have the corona. And the corona, it forms the Earth's outer atmosphere. So the corona is only visible during an eclipse. So that's the only time that you can see it. Can anybody tell me why the corona is only visible during an eclipse? Yes, Tim?
Because it actually covers the sun so bright that it just disappears. And we can't see the actual sun. That's why you see because the sun is actually illuminating.
Okay, so it's very like faint and the brightness
you
from
can't see it because it's so bright from the sun. But then when the sun's actually covered, the light from the sun actually illuminates it.
So why can't we see the corona like through one of those devices that block out the sun?
Well, maybe it's because the corona only happens when there's a solar eclipse.
No. The corona is always there. We just can't always see it unless there's a solar eclipse because the moon, it covers the sun, and so we're not getting the it's very faint, and so the atmosphere of the Earth is receiving no illumination from the sun. So that's what it is. So we're able to actually see the corona at that point. And next we have the chromosphere, which is a thin region below the corona, and it's approximately 300,000 kilometers thick. And next is the photosphere. The photosphere is the visible part of the sun that we can see from Earth. So we have first the corona, and then the chromosphere, and then the photosphere. You see it's like the outside, this very thin layer. And this is what we can actually see. So remember that. Think about, you're taking a photo of something, and what you can see is photosphere. That might help you remember that. And next we have the convection zone. Can anybody tell me what convection means? Yes, Dan?
Is it a way to, one of the ways to give out energy?
Good. Can you tell me how it gives out energy?
It takes it from one object and puts it into the other, colder object, and then gives it to the other. No, it takes the energy from the hotter object and uses the connection.
Are you thinking conduction?
Is that what it is? Convection? Maybe convection is the one where
Convection is like exactly what you see here. The cooler molecules are sinking to the bottom, and the hotter molecules are going to the top. So it creates like this circular motion. See? So just remember that convection zone is this circular motion right here. And this layer is approximately 200,000 kilometers thick, and it is below the photosphere. And next we have the radiative zone. And this is a very dense area, about 300,000 kilometers thick. Can anyone tell me what radiation is? Yes.
Not that, but when we were talking about the convection zone, we said that the hotter molecules go to the top of the molecules and top, and the core is the hottest part of the sun.
The core is the hottest part of the sun.
since the hotter molecules are
Yeah, because the hotter molecules, think about it, the hotter molecules are going to be like right here. So they're going to rise up, and then the cooler molecules are going to sink back down and get heated and go back up again because it's hotter here. Okay, does that answer your question?
And the core is just
The core is actually, we're getting to the core. The core is next, and the core is at the sun's center. And basically the core is where all of the light or all of the energy is generated. 99% of the sun's energy is generated in the core. So although the sun, it appears to have a solid surface, it doesn't. actually just gases and, anybody have any questions about the different parts of the different layers of the sun? Can anybody come up with some way for us to remember these? So we have first corona, and then we have convection zone. I think we have a better picture than this one. I like this picture better. Yeah, this one. See how it shows us the corona is the outside, and then we have the chromosphere, and then the photosphere, then the convection, then the radiative zone, and then the core. Yes?
I would think of it as like the sun is a giant egg
Okay.
that is a really, really hot egg. It's been in the incubator for a long time. And we see the egg from a long way away. And the egg, at the core is the center of the egg where the chicken is.
Okay.
And the radiative zone is like that little gooey stuff that surrounds the egg. But it's really
Okay.
hot too. So it's not as hot as the core, but almost as hot as almost. And it also feeds the side that's outside of the egg, which is like a shell of the egg. It's not really a shell of the egg, because that's the photosphere.
Okay, the part that we can see.
And then the corona is the
The smell that it gives off
smell-
when
the
it's
smell that
when
gives
it's
off.
rotten.
Exactly. Yes.
Okay. I was thinking of it always as like the core of an apple. That's how I remember the core is like the center. So that's an easy way to remember it. Yes.
Can I explain on Dan?
Sure.
And then the chicken hatches is when the little happens. And then a giant space chicken comes out and eats the
Okay.
Black hole.
How much of it dies?
Okay. So now we have energy production in the sun. So we know that the sun has been shining on Earth for about 4.6 billion years. Okay? And some type of burning fuel was thought to be the source of the energy. Do you think that burning fuel could be a method in which the sun generates energy?
No.
Just burning fuel? Why not?
Well, yes.
Just burning fuel alone.
You mean burning no. But yeah, depends on the fuel that you're burning.
Well, we know it's hydrogen and helium, right?
Yeah.
Okay, so do you think that that could be the main source of energy? Just burning fuel?
No, I don't think that's the only sort of fuel.
Okay, good, because if the sun were just simply burning fuel, the scientists say that it would have burned out after 10,000 years. So we know that that cannot be the only method in which the sun generates energy. Yes, John?
How do people, like, how do scientists know, like, where the core is, or, like, if there is a core?
They don't.
Study.
It's theories.
Well, they've,
Studying makes theories.
You can't, like, go inside this.
no, you can't. It's way too hot.
Can't push it.
Wouldn't you die before you reach the sun?
They actually came up with this hypothesis using Einstein's E equals mc squared.